Have you ever really thought about the machine that weaves, well, pretty much everything around us? Today, we're going to unravel the incredible story of the loom. I mean, this is a machine that has literally woven the fabric of our world, from ancient tapestries all the way to the high-tech materials you'd find in a fighter jet. For thousands and thousands of years, this was weaving. It was a totally human manual process. Just look at this hand loom. Every single thread that goes from left to right had to be passed through by hand. You could imagine, it was slow, it was tough work, and the widest piece of cloth you could make, well, that was limited by how far you could reach.
So that brings up the big question, right? How did this really intimate hands-on craft
Somehow turn into this? I mean, look at that. It's a room packed with machines, moving so fast they're just a blur, churning out massive amounts of fabric with barely any human touch. How did it evolve into this crazy, high-speed, automated industry? How in the world did we bridge that massive gap? Well, that's exactly the journey we're about to take. All right, let's get into it. To really get how the loom evolved, first we have to understand the basic problem it's trying to solve. And it's actually pretty simple. How do you efficiently crisscross two sets of threads? You've got the stationary vertical threads, those are called the warp, and then you have the thread that travels across them. That's the weft. And here's the cool part. It turns out that no matter how basic or how ridiculously complex the loom is, the whole process comes down to just three essential repeating motions. This is the heart of all weaving. Okay, so the most critical first step is called shedding. What happens is the long vertical warp threads get split into two layers, one on top and one on the bottom. And this creates a kind of tunnel, that's the shed, and it's the perfect little path for that horizontal weft thread to shoot right through. Seriously, this one action is the absolute foundation of everything. So for a long, long time, the biggest challenge was just, how do we do those three steps faster? You know, early weavers were totally limited by their own physical strength and reach. That meant cloth was super expensive and took forever to make. So the first big push in innovation, it was all about one thing: speed. And this timeline here, it really shows the game-changing moments. Around the year 1000, you get the treadle loom, which was awesome because it let weavers use foot pedals to make the shed, freeing up their hands. But the real explosion of progress, oh, that came during the Industrial Revolution. One of the absolute biggest breakthroughs was John Kay's flying shuttle. See, before this, a weaver literally had to throw the shuttle, the thing carrying the weft thread, from one hand to the other. Kay's brilliant idea was to use a cord to just shoot the shuttle across the loom. Bam! This instantly doubled a weaver's speed. And, for the very first time, it meant a single person could weave cloth that was wider than their own arm span. A total game changer. And right after that came an even bigger leap. In 1785, a guy named Edmund Cartwright comes up with the first power loom. This thing wasn't powered by human muscle anymore. It was powered by a machine. At first it was water power, and then later, steam. And this was the turning point. It didn't just revolutionize textiles, it helped kickstart the entire Industrial Revolution. Weaving moved out of little cottages into giant factories, and the era of mass production had begun. Okay, so the looms are fast now. Awesome. But what about making things, pretty? How do you tell one of these powerful machines to create a really complex, artistic pattern? This was a totally different kind of problem, and it needed a whole new way of thinking. I mean, really think about it for a second. Weaving a plain, solid color cloth is one thing. But how could a purely mechanical machine with no computer, no brain, know which specific threads to lift out of thousands at exactly the right time to weave a picture of, say, a flower? Well, the answer came in 1801 from Joseph Marie Jacquard, and honestly, it was pure genius. He came up with a system where the entire pattern was stored as a series of holes punched into paper cards. It was simple. A hole meant lift this thread, and no hole meant leave this thread down. It was basically a binary code on paper. And you have to understand, this wasn't just a big deal for weaving. This was a monumental leap for technology itself. The Jacquard loom was, for all intents and purposes, the world's first programmable machine. It's a direct ancestor of the computer you're probably watching this on right now. So, for more than 200 years, the flying shuttle was king. But by the time we get to the 20th century, it had become a major problem. It was the bottleneck. I mean, think about it. Violently throwing a heavy block of wood back and forth is super noisy. It can be dangerous. And there's a hard limit on how fast you can possibly do it.
So, the move to what we call shuttle-less technology, well, that brought huge improvements across the board. Speeds just skyrocketed. The noise level in factories dropped like a rock, and the very real danger of a shuttle flying off the loom and hurting someone was gone, just eliminated.
So instead of that clunky old shuttle, modern looms use much more, well, elegant solutions. You've got air-jet looms that literally blast the thread across with a puff of compressed air. Water-jet looms do the same thing, but with a super high-pressure stream of water. And then there are rapier looms, which use these long, skinny robotic arms to carry the thread across with incredible speed and precision. But now, with looms running at thousands of picks, that's a single pass of the weft thread, per minute, all that amazing speed created a brand new problem: control. How do you start, stop, and manage these incredibly powerful machines with the kind of millisecond precision you need to make sure the fabric is perfect? You know, early factories used what's called a group drive system. Picture this: one giant engine in the building driving a whole forest of overhead belts and shafts that powered everything. As you can imagine, it was not only inefficient, it was incredibly dangerous. The solution was to give each and every loom its own motor, and in a way, its own brain. That's the individual drive. But even that early individual control was still all mechanical. Stopping the loom meant physically clamping down with a friction clutch or a brake shoe. Think about the brakes on an old car. These parts were slow to react, they wore out all the time, and they just didn't have the kind of fine-tuned precision you need for modern high-speed weaving. The modern solution, though, is so much smarter. Today's looms use direct drive motors where the motor that makes it go is also the brake that makes it stop. It's all done with sophisticated electronics that give instant start and stop commands. There's no clutch to wear out, no brake pads to replace, just perfect, repeatable electronic precision every single time. And that pretty much brings us up to today. This whole incredible story, this journey of solving one problem after another. First speed, then complexity, then control. It's still going. It's far from over. Think about it. We started out weaving simple cloth from things like cotton and flax. Today, looms are creating complex, three-dimensional structures out of carbon fiber for the aerospace industry. But it's still the same fundamental motions: shedding, picking, and beating up, that are building the literal materials of the future. So that leaves us with one last big question. If we've come this far, what are we going to create next?